All right, let's go ahead and move on here. We have Darrin Williams, the Darrin Williams on the line. Um, Darrin is going to be talking to us. Darrin runs the survey department for Wall Consulting Group. Darn it, Darrin, I know you sent me your bio, but when I printed this out, I didn't get that on there. If you wouldn't mind just quick sharing a quick little bio of yourself, if you don't mind. Darrin's going to be talking to us about how they've utilized drones and to augment their survey workflows. So with that, I'll go ahead and turn the time over to you, Darrin. Oh, by the way, it is coming up on 3 o'clock. If you can take between 20 and 25 minutes, we'd be golden there, my friend.
No problem. Keep it short and sweet. Well, thanks for having me, and thanks to all the presenters that I've listened to so far. You guys have all had some really great presentations. I want to try and make this simple. Troy wanted me to present on how we use our drones and some of our survey workflows. After watching some of these presentations, like I said, technology is amazing, and you guys are doing some really technical things. I should have almost renamed this Drones for Dummies or something like that, because I really just want to show you how I use our drone on 95% of our projects. So a little bit about me. Like Troy said, I am the survey manager at Wall Consultant Group. I've been surveying for about 16 years, mostly northern Utah, Salt Lake Valley area. Obviously, this day and age, it's super easy. We survey statewide. We were everywhere from Escalante to Idaho to Wendover to Evanston last year. We do, I think, what the majority of us do a lot of survey and mapping, topos, boundary surveys, everything from your one lot residential stuff up to, several mile corridors. We do a lot of transportation engineering. That's we have about 80 employees, but the bulk of our staff is transportation, civil site design, surveying. That's a little bit. So just want to kind of run through the basics of how we use the drone. And again, we follow kind of this workflow on every single project, whether it's a small flight or big flight. We found that doing it the same way every time eliminates a lot of the headaches you run into with using new technology. We were getting a lot of requests to, oh, this is just a small project, cut corners, or there's, depending on the project, kind of getting outside of following this process. And maybe even, and so we just started doing drone work about 2.5 years ago. And so I'm getting into it. I didn't have a lot of experience with it. And it could, I think with any technology, it could be kind of overwhelming, going back to, I remember using the first robot and, like, how is this? Are we going to figure out how to do this compared to total station and radios? Where's my radio and stuff like that, or even GPS? Can I trust this? And so it was overwhelming at first, but again, just to kind of dumb this down and hopefully not, oversimplify it, these are the steps we go through. So the first thing is creating a flight plan, and that's really just either yourself or the end user, the designer and engineer, getting a KMZ of the area they want included. This really helped us, so up front, we knew exactly what our limits were, and it helped us plan throughout the project. The other big thing in this stage too is checking airspace. We do a lot of work in Salt Lake Valley and northern Utah, so the big restrictions there are Salt Lake International Airport and Weber Davis County. You got the Hill Air Force Base and Ogden Airport. And so a lot of times in the proposal phase, we've got this plan. We're gonna fly the drone. This be a piece of cake, and then you run into, oh man, we can't fly, or we're restricted to a flight height, and that, depending on your project, you might be up against a tight deadline or schedule. So knowing that up front, there's websites it's easy to check that, but that was a big learning curve for us. We proposed on a big project in Augment. it was a zero flight height, and Augment has a much different process for getting flight approval and clearance to fly. So that was a big learning curve for us there. The next thing we do is send the field crew out and set some aerial targets. Again, I mentioned that we would try and cut some of these corners. This isn't a big deal. Maybe we'd have an intersection project, and we're just gonna design over the aerial. We're not gonna have any topo or anything like that. And then lo and behold, hey, can you go out and stake some stuff or go collect some topo? And it's really challenging to correlate field data to stuff you've collected with the aerial if you didn't start with ground control points. So super simple step. We actually have a pilot that flies all our drone pilot that flies all our projects. He's even got the equipment in his truck. He can just paint targets even if we're not going to shoot him before he flies. But so we set targets on every project, and they're really simple. What we do is we set a nail, and we've got a little stencil. We'll paint a simple target. We're talking a foot and a half wide. The quality of the image, it's very easy to see some of these targets. And obviously sometimes you can't paint targets, so classic old school, we're going to put some flagging like the old panels. We just nail down a little bit of flagging. You can also buy some of the pre-made targets that you can nail down. Next step, obviously, we fly it. In all honesty, this is the easiest part. First getting into drones, it's overwhelming. How do we do this? The flight is the easiest and sometimes least impressive part. We had a lot of clients we would be flying. They want to come out and see how this all works, and it's really a little anticlimactic. So most of these flights are very short. It's quite amazing the area you can cover. We mostly fly a Phantom for RTK, and you can cover quite a larger area in 45 minutes. So again, I just bring that up. I wouldn't be intimidated by that part. Really, it's like the quickest, easiest part of the process for us. The next thing is processing. Now, going from the easiest to probably the hardest, this was something, it felt like there's so many different softwares out there. Where do we start? What are we going to use to process all this data we collected? We ended up going with Pix4D. We actually used Pix4D Mapper. It's very easy to upload our data from the drone into that, and it's got some really basic options for processing your data. With any of this, going back to other survey methods like the robot or GPS, those tools do a lot of different things that we don't use all the time. Maybe doing static or DRing with the robot. There are things that you can do with it, but we don't use it very often. Same thing with Pix4D or the drone. There's lots of things you can do with these things, but most of the programs are pretty straightforward and simple. Again, I go back to, we were overwhelmed and a little intimidated by it. They make it pretty easy. I think these are all ones we've used: Pix4D, Drone Deploy, TVC. They all are pretty simple to use, to be honest. They make it easy to upload your data and give you great output options. The main deliverables we use, again, you can, through that processing, there's lots of different exportable options. I think the main thing most surveyors will use is your aerial. We were just talking, somebody else asked a question about the 2012 aerials. We've been in the same boat. You have access to some free Google aerials that don't fit well. The AGRC 2012s are getting outdated. We use the aerial for everything. Every project, it's a standard scope item. We just fly every project. The flights are so quick. You're already going to be out there most of the time for the targets. Just do a quick flight, because that aerial will be used throughout the entire project. And really, once your engineers or clients get a taste for it, it feels weird when you don't have it. They'll be asking for it. The other thing that is super easy to use is point cloud. Almost all your programs, whether Bentley, Autodesk, TVC, any of these, you can use the point cloud in those programs. So we use that a lot. In the last step, I think I'd say we were maybe a little slow to incorporate this. I think we were so enamored with the tools and the process, and the quoted specs on it. But we found that it's really important to still have quality control. You still do checks with your robots. You still do checks with your GPS. You need to do your checks with your drones too. You can't just go off of what the specs are for accuracy, or you need to have your checks to make sure that through your processing and all those other steps, you don't have any mistakes. And so we try and field verify everything. Ground truthing, if we use the aerial or the point cloud, we still make sure we go out and get some check shots and do our QC on that. So from our workflow, like I mentioned, we use the aerial on everything. Some of the main uses for that is boundary analysis. Think about, the biggest one for me has been breaking down a block. Sometimes it is hard to go through. Maybe you don't have good monumentation, so you're looking at occupational evidence in the block, trying to get into backyards to locate fences and other lines of occupation or buildings. Now, we're using these aerials that you can see the cracks in the pavement. Where some of the cameras, you can read the letters on the manholes. So to be able to just, using an aerial, accurately drawing some fences, because let's all be honest, when you're out shooting a fence, how accurate, we're a couple tenths most of the time shooting fences anyways. It's just as easy to be tracing these fences from an aerial. There's also some things that maybe when you're out there in the field analyzing a boundary, it's hard to do a full topo of the huge area. Maybe you get a good topo on your property, but you'll see stuff on the roads or joiners that you weren't thinking you needed, but now you can, look at that data in your aerial and help that in your boundary determination. Topographic surveys, again, that's when you're even just drawing in your line work from the field crew, it's amazing to have that high accuracy aerial behind it. It's even helped us in some cases recognize some field procedures that need to be modified. You start seeing some rod tilt and stuff like that, where it looks like we're getting a little sloppy on some of our shots, and we can fix that. Or maybe we can see where we missed a couple points, and this curve needs to be drawn different. Again, it's one of those things. Once you start drawing an aerial or a topo with that aerial behind it, then you don't have it. You wonder how you ever did it before. And then the design, like I said, once our designers got a taste for the aerial, it quickly went from the conversation of, can we add this to our scope? Is the cost justified? To, it's not even a question anymore. It's just included every time, because those designers so often need to look at that aerial to maybe better understand the topo and how their design is going to relate to the adjoining properties, or what impacts will be in the design. A huge thing has been just replacing concrete. Where are we going to tie into this driveway? Now we can see those joint lines and decide, we need to replace these panels. Our firm also does a lot of concrete inspection for like I-215. So they used to go out and stand on the side of the freeway and just try and visually inspect these cracks in the concrete. So you're either on the shoulder or the outside lane trying to look over and count panels and determine cracks. Or now we can just fly that. And even if they're unsure, they can review that later in the office. It's not a one and done in the field. I hope my notes were good. That's been a huge thing for safety for us. Even the topo, the safety aspect of it. being out in heavy traffic, trying to capture striping and stuff like that, it's so easy to just draw striping in from an aerial. Moving on, the other big deliverable is the point cloud. As I just mentioned, roadway mapping, we do a lot of, a lot of transportation, and we'll be out in some pretty busy intersections. This is one we did last year on US 6. So you can see this is just the point cloud, and this is just the basic flight, right? So you can see how much data we got from this point cloud from just a typical flight. And what we did with that is we were able to extract all the data we needed for the roadway without having field crews out here in these 5-6 lane sections, or even in this busy intersection. Some really unique striping and lane things going on here that would make me very nervous to have a field crew out, or you'd be forced to do some traffic control stuff to collect that data. And again, we were able to extract all the needed information from the roadway, and then we just simply had to go back and we did a lot of QC shots to verify that stuff we extracted was meeting the standards for our internal process and for our client. I'm gonna try and show an aerial here too. This is a pretty big project, but I wanted to show you, again, just kind of a standard. Let me do it. I think I'm taxing my computer here a little bit today on what we're presenting. But going back to the other uses for the point cloud, it's really easy to map a large area, whether it's a field or I don't know, not that it takes a ton of time, so I guess I wanted to make this point that the drone is a tool just like your GPS, your level, your robot. It's not something that replaces any of them, or at least in my opinion. We started that when we first got the drone. Let's fly a project and we're just going to extract everything. We're not going to get any conventional shots. For us, this is really just a supplemental tool to it's just another thing in our toolbox. And so, large areas, instead of having somebody walk a grid in a field or something like that, we can quickly extract some points and grid that out. Supplemental topo. I use this example because we have a project in Santa Quinn right now. It's a 2-hour drive one way for our field crew. If we miss something on that site, you're 4 hours to, 2 hours each way to go back and get something. So we very frequently will use the point cloud to supplement our topo. Maybe we need some more data, or maybe even the designers needed some more topo in an area they weren't planning. Really easy just to grab some more points out of the point cloud without making a whole nother trip. I also put on here limited access. I think that's the nice way of saying without trespassing or something like that. We often have confrontational landowners that don't want us on their property, and so to help ourselves and help our clients, we're able to collect, extract some of that data without having to, without upsetting some of the residents. See where we at. Another shocking thing that we use a lot is the aspect shots. You said the flights are super quick, a lot of times 30, 45 minutes. So we also have the pilot gets some aspect shots while they're out there. So this is kind of an example of a project we did in Ogden Canyon where we had him take some aspect shots while he's out there, so getting some different, I think back when I was in the field, we would take the office digital camera with us, get a bunch of site photos and upload them later. Now we're getting these really unique aspect shots of our project area, the other designers, we have a lot of structure people on this project that, they wanted to see more of how some of these bridges are working. We even had limited street view, so we use Google Street View all the time. This is a similar thing. We're basically flying. I'm going to kind of go through these quick, but you can kind of see all the different angles that you'd almost see from like street view. And it's not something that's probably marketed enough with the drones, but it's something that we use a lot, or even for, let's see, am I still sharing my slides? I wanted to show, this is another drone photo that we use for a project website. These were just, aspect photos that we collected while we were on site. It's something kind of a hidden feature that we weren't expecting by buying the drone, but that we use a lot. Some of the lessons we learned, I think I already kind of hit on some of these, but our ground control points, we got burned a few times by cutting that corner. It really helps with ground truthing or coming back to the project later. Makes processing way easier. Restricted airspace, I think that takes a little bit of time to learn some of the processes with Salt Lake Airport or Ogden Airport, stuff like that. Segmenting large projects, we started just, we'd fly an intersection like, oh, that works great. We flew a small site, works great. Well, let's start flying. We started flying bigger and bigger projects, and it didn't take long for us to realize we need to be careful on how big of an area you fly, both for processing and for using the deliverables. Having these huge aerials and point clouds can be difficult to work with. But see, I was very worried about restricted airspace. I got on here again. The ground truthing, quality control, again, making sure that it's still a survey tool. You still need to, have those good processes to make sure that you've got accurate data. Processing times, this is something that I wanted to bring up too. I immediately thought, we're going to need a supercomputer to process this. In all honesty, I've got a laptop with 16 gigs of RAM. You can process this stuff. You're not going to be able to work on other stuff, but for me, a lot of it was set it and forget it. I had a bunch of used parts, and I just have a computer in the unfinished part of my basement that I remote into and let that crank on some of these projects. But the lesson learned there too is if some of these take 24 to 48 hours to process, if it doesn't process well, you're gonna have to troubleshoot it and reprocess it. That adds another 2 days. So we did run into that where it was hard to commit to deadlines because sometimes you didn't know how well it was going to process, if the data was going to be good enough for what the client was needing. I think that's it. I don't know how fast I started running through that quick, Troy, but open it up to questions. How do I do on time?
Doing good. Yes, let's go ahead and see if there's any questions. I didn't see any come through on the chat. Oh, one moment. Yes, we got a question here. Darrin, do you ever use post PPK with your drone flight? If yes, what software what software do you process the corrections with?
We don't use post PPK, at least I don't think. Ours is an RTK drone, so it does connect to the VRS. And so that's, the kind of the correction source. It does have the ability to use a remote base station too. But, going back to Sean's last slide on connectivity and reliability, we've had really great success with the connectivity and reliability with our drone. Yeah, the VRS work great. Other than we did think for a little while we were trying to share a VRS login, and that because you fly such small amounts of time that we were trying to share it, and very quickly we bought a second one.
Gotcha. A second question, do you need an account to use the VRS? I've had a lot of trouble connecting.
Yeah.
You definitely need to have an account.
Yeah. Yeah, and it's the same thing you use with your GPS. You know, like I said, we were just using the GPS login we had. We were flying such a limited amount of time. It wasn't until we started getting busier that it wasn't worth trying to juggle that one login. And until Troy realized we were using his, and then we started getting kicked out of that one.
All right. How are you connecting how are you connecting to the internet out in the field? That maybe would help more than anything.
We use a hotspot,
Okay.
both with sometimes that's a cell phone hotspot. We do have a dedicated hotspot as well, but some of the guys prefer to just use the one on their cell phone. They don't like carrying around two. So it's super, these new smartphones.
Do you
Button
know
right at
what
the top turn that
provider
on.
do you know what provider you're typically using?
Our primary one is AT&T, but we do
Oh,
use
okay.
we have T-Mobile and Verizon as well.
All right. For the customer that asked that might be the biggest part of it is their provider. But the hotspot also can be some of the older hotspots might be a little bit more tricky to connect to, or even one of the newer ones maybe. So
Yeah, we also in areas we didn't have great cell service, using the ground control points really helps with processing that data. I think you
yeah.
would it would be a little bit difficult to process some of that drone imagery without the RTK solution and without ground control points. But
Okay. I think that's it. Oh, yeah, I think that's the questions that we had. Nice job, Darrin. Appreciate that.
I have two other questions. How much do you rely on?
Did you hear that, Darrin?
no, can you repeat the question?
Well, just in the chat.
What?
One says, how much do you rely on drone data for curb, gutter, and sidewalks? Or do you still survey those features with GPS or total station? The next one says, between Trimble Business Center and Pix4D, which program is easier?
I don't think you've ever used TBC, right, Darrin, for photogrammetry processing?
We don't use it for photogrammetry, but we do for point cloud extraction. Primarily Pix4D for our processing. We have used Drone Deploy. Drone Deploy is pretty nice. Some of these, I think there's several different ones where you can send your data off and you get it back very quick. The cost on that didn't make sense for us, even though sometimes you look at the software cost, paying for each individual process would have been more expensive in the long run. The other question about how much do we use it for curb, gutter, sidewalk? Very little. That was, that was a lesson learned. We flew the site, and there's lots of tools in these programs, and they make it look so easy to extract that stuff. But to be honest, to meet the accuracy that we hold our crews to, and that we expect for our client, we do that. We do that conventionally still. We just ran into too many issues where you'd have maybe some trying to think, grass overgrown on the curb, makes it really hard to see that top back curb. Cars parked on the shoulder, little things here and there that were just too much that to get good curb and sidewalk lines. And I think also just for accuracy standards, I have much more confidence. I don't have that much confidence in the point cloud for that stuff.
So you're still using the ortho-rectified mosaics and photos for line work and contextual information, but definitely not on the topo side of it, at least for hard surfaces. I think that's pretty standard practice out there. So
yeah, I think when you look at kind of, I don't know, what makes sense in my mind is you're paying $20,000 for a robot and $4,000 for the drone. There's a reason there's a cost difference there. That if we're mapping that, we're doing quality mapping on hardscape, you need to use the right tool.